All right, let's go and get started. And I want to start by drilling over your sum of difference identities. Of course, the first two, we're not going to read them quite as it's all spelled out because we've got a faster, easier way to remember these. Class A with me slowly. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Now a little bit faster. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Faster still. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Very good. Now, the next ones, we're not going to do the thetas and the phis, but we're going to read everything else for the tangent, and it's not cool, but we're going to do it anyway. Tangent plus or minus tangent all over 1 minus plus tangent tangent. Again, tangent plus or minus tangent all over 1 minus plus tangent tangent. One last time. Tangent plus or minus tangent all over 1 minus plus tangent tangent. And that's what you were using on your homework last night, as you were supposed to find, first of all, that out of the way, the sine of 165 degrees. Now, they didn't tell you how to make 165 degrees out of two special angles. You had to figure that out. Which two special angles did you use, Chris?
120 and 45.
Outstanding. 120 degrees and 45 degrees added together. Anyone use something different? All y'all did the 120 plus 45? That's fine. You could have done 135 and 30 if you wanted to. What did you do?
45 and 30 because I was confused. I had 165 and I had...
And you said 165 equals 45 plus 30?
No, like 180. There's 15 degrees between them. And I don't know.
Okay, does it make sense now though? We could have done 225 minus 60.
No.
I don't know why you would, but you could have, right? You could have done 315 minus 150. Those are both special angles. Literally, there's an endless number of ways to make 165, but they have to both be special angles. And again, that doesn't mean 0, 30, 45, 60, 90. It could be 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, right? Any of those would work, right? You just pick the angles that work for you. I think this is probably the easiest way to approach it. And we notice it's sine. Sum or difference, in this case, sum identity. So we write out sine, cosine, cosine, sine. No indicator to change the SIG in, so I'm going to keep the positive, and then I drop the angles in.
120, 45, 120, 45.
And then I think to myself, well, 120, what's the reference angle?
30. Wait.
60, because remember, always measure from 180 in quadrants 2 and 3, 360 in quadrant 4. And what quadrant, of course, is 120?
2.
Quadrant 2. All right, so sine of 60, you're going to have to draw your own special triangles when there are other room that doesn't have them up. Square root of 3 over 2. And in quadrant 2, sine is?
Positive.
So positive square root of 3 over 2. What's the cosine of 45?
Square root of 2 over 2.
Square root of 2 over 2. What's the cosine of 60?
I got negative 1/2.
1/2, but in quadrant 2 it is?
Negative.
So negative half. And sine of 45?
Square root of 2 over 2.
What do we get if we multiply square root of 3 over 2 times square root of 2 over 2?
Square root of 6 over 4.
And negative 1/2 times square root of 2 over 2?
Negative square root of 2 over 4.
And we put it all together over a common denominator. Square root of 6 minus square root of 2.
That's
And
why
there's our answer.
Yeah, at the bottom I didn't do it like that. I don't know how I did it, but I got square root of 3 minus 1 over 2.
Oh my, all right, questions. Let's take a look at the next one, which was to find the cosine.
Would that have been most of the points if would that have been a few extra credit?
Well, let me talk it through. I get partial credit for identifying, not a lot, but I do get some partial credit for identifying what angles I could use. Again, as long as it is a pair of angles that works appropriately, it'll work. By the way, should we mix it up and do different angles this time? No, we don't want to. Okay. And you get partial credit. You get a lot more partial credit for correctly writing the identity, which for cosine is cosine, cosine, sine, sine, sine. Where the first of those signs in the sine, sine, sine is to change whatever you had here. Since I had a plus, I put a minus. And then I drop in the angles.
120, 45, 45.
All right. And we already know, because we looked at it earlier, this is a quadrant 2 reference angle 60. What's the cosine of 60?
Negative 1/2.
Half. In quadrant 2 it is negative 1/2. Cosine 45.
Square root of 2 over 2.
That's a 2, it just didn't look like a 2. All right, then minus, all right, sine of 60.
Square root of 3 over 2.
In quadrant 2,
Positive.
sine of 45.
Square root of 2 over 2.
Negative 1/2 times positive square root of 2 over 2.
Negative square root of 2 over 4.
Here I've got negative, positive, positive. That's one negative, so my answer here is negative.
6 over 4.
And here, if you wanted to, you could factor out a negative first to make them both positives. And that would give you negative out in front, because it's been factored out. Square root of 2 plus square root of 6, all over 4. That's a horrible looking 2. And there's my answer. Now we have this for the next one. Questions. You see about how the partial, then you get partial credit for figuring out these numbers, partial credit for multiplying correctly, partial credit for putting it all together correctly. So yeah, there's a lot of partial credit that could be gotten here. Questions?
I wish I just had the right angles.
Yeah, so for instance, the tangent of 165, Ethan, I'm going to have you pick, no, I like this because the reference angle of 120 is 60. And I said for tangent, I like 60 degree angles. Anything that's a form of 30, I hate, for tangent specifically. So yeah, let's roll with the 120 plus 45 degrees. And we need to write out our identity, class. Tangent plus or minus tangent all over 1 minus plus tangent tangent. And of course the tangent of, this is again quadrant 2. Well, I guess if I were to write them in, I should write in the 120 and the 45, the 120 and the 45. That's right. All right, now, tangent 120. Well, that's quadrant 2, reference angle 60. What is the tangent of 60?
Square root of 3.
Square root of 3. Quadrant 2 tangent is negative square root of 3. What's the tangent of 45? 1. All over 1 minus tangent of 120
Square root of 3.
times 1, which I don't really have to write that. All right, I've got a 2-term, radical denominator. Got to multiply by the conjugate, which is
1 plus square root of 3.
Is this his problem or is it everyone?
That's everyone.
Okay.
Oh, okay.
oh, we missed something. I just realized something's not right here.
Yeah, I was thinking.
Tangent of 120, square root of 3, but negative. So it's 1 minus negative square root of 3, not just square root of 3, negative square root of 3, and minus a negative becomes plus a positive. There we go, Jamie. Jamie was like, no, stop. And so the conjugate is actually 1 minus square
Why are you looking at me?
1 minus square root of 3. You're the one right there in front of me at the moment. Like, this lines up right there with Chris. All right? They're kind of in my peripheral. Peripheral. All right, so multiply by the conjugate. The whole point of multiplying by the conjugate is that in the denominator, I would have a
Common denominator.
difference of squares. When I square the first square, the last, put a minus sign. Square the first,
1.
square the last, 3, put a minus sign.
Negative.
So what is my negative 3?
Negative 2.
Negative 2. In the top, let's just FOIL. First,
3.
negative square root of 3. Outer,
3.
positive 3. Yeah, positive square root of 9, which becomes positive 3. Inner,
1.
positive 1. Last,
Negative
negative square root of 3. Now I've got a 3 plus 1,
4.
and I've got a negative square root of 3, negative square root of 3.
2 negative square root.
Negative 2 square root of 3. All divided by negative 2. 4 divided by negative 2. Negative 2. Negative 2 square root of 3 divided by negative 2.
Negative 1.
Positive 1
yeah.
times the square root of 3, or just positive square root of 3. And there are my answers for number, whatever it was.
2.
Number 2. Questions on number 2? The curl on that thing is bugging me. OCD a little bit. Yeah. Let me do this. What? On the poster?
Just sticky tack? Can I get some?
No. When you're a teacher, yes. But not until then. Alright, questions on this?
There's like a legal limit to buy.
There is, yes. Yep. You know, if you don't teach your credentials, can't buy sticky tack. Alright. Actually, that's not true. But anyway, alright.
I'm gonna bring like a whole box of this tomorrow.
Let's move on to number 5. And what are we fighting in number 5, Ethan? Page 116, Ethan.
I just already.
Oh, Ethan.
225. Sine of what?
Sine of what?
225 degrees.
255
Oh,
degrees.
I did 225.
Well, see, 225 is already a special angle.
Yeah, that's what. Yeah.
So we want 255 because we want to put two special angles together. Now, Ethan, sounds like we didn't do it quite right. That's okay, not upset, but I'm going to give you the chance to prove to yourself that you got this. Two angles I can put together to make 255 degrees.
225.
Plus
30.
All right. Two special angles. Now we know that 225 is in quadrant.
3.
Reference angle.
45.
I'm about to say, don't make this hard. It ends in 5. It's got to be 45 if it's a special angle at all. There we go. So we got a quadrant 3 reference angle 45. We need to write out the sum difference identity for sine, Ethan.
Oh, sine, cosine, cosine, sine.
And again, no indicator to change the SIGN, so I'm going to keep a plus between these. And we got 225, 30. 225, 30. All right, Ethan, what's the sine of 45?
Square root of 2.
In quadrant 3?
Negative.
What is the cosine of 30?
Square root of 3 over square root of 3. I thought it was square root. 2. Square root of 3.
Over 2, adjacent over hypotenuse, so we got the 2. Plus, what's the cosine of 45?
Square root of 2.
In quadrant 3?
Positive. No, negative.
And what's the sine of 30?
Square root of 2.
Opposite over hypotenuse?
Oh, yeah. 1 over 2.
1 over 2. All right, we multiply. Negative square root of 2 over 2 times 3 over 2?
Negative square root of 6 over 4.
And positive ends up giving me,
Positive. Or negative.
yeah, only one negative, so that's odd, so it stays negative. Square root of 2 over 2, 1 over 2.
Square root of 2 over 4.
Since they're both negative, I should probably factor it out. If they're both negative, you want to factor that out because you don't want a first term negative, right? And you can't flip-flop it, so factor out the negative to get what for our answer?
Square root of 6 plus square root of 2 over 4.
But don't forget the negative you factored out stays in front of the grouping, right? Because technically this fraction bar takes the place of our parentheses we had. Okay, questions on that? Anyone have that? All right. You used 225. How'd you get that?
I don't know. It's conscious to raise my hands.
He's just a perpetual habitual liar. All right. Well, habitual liar gets a chance to find the cosine of 225 degrees. And Chris, I want you to use something other than 225 and 30.
180, 90? No, wait.
That'd be 270.
I want to use 180, but I can't use 180.
You can't use 180. No, 180 is not going to work because 180 and 75 doesn't work.
He used 225 and 30.
He did.
145 and 90? No, that's still.
Well, that'd be 235. 145 isn't special.
135. Is 135 special?
135 is special.
120, 135.
Ah, good. All right, so there's a way to do it. Again, use your creativity.
Oh, that's going to be hard. That's going to be hard. That's going to be annoying.
No, it's not. It's going to be, okay, maybe a little. Because both of these are quadrant 2 angles. The first is a reference angle of
45.
Let's say if it's special and ends in 5, it's got to be reference angle 45. The other is reference angle 60. All right, so we write out our sum difference identity for cosine.
Cosine, cosine, sine, sine, sine. Positives.
Good, cosine, cosine, sine becomes negative, sine, sine. And then we drop in our
Angles.
135, 120, 135, 120. Okay, and then we say, okay, well, what is the cosine of 45?
1 over square root of 2.
Which becomes
2 over 2.
All right, and in quadrant 2,
Negative.
what's the cosine of 60?
1 over 2.
In quadrant 2,
Negative.
we have a minus here. All right, what's the sine of 45?
Square root of 2 over 2.
In quadrant 2.
Negative. Positive, positive.
What's the sine of 60?
Square root of 3 over 2.
In quadrant 2.
Positive.
Negative square root of 2 times negative a half.
Positive square root of 2 over 4.
Negative, positive, positive.
Negative square root of 6 over 4.
What did I simplify it to?
Square root of 4 over 4.
Careful. Can you subtract square root of 2 minus square root of 6?
No.
Nope. My one piece of chalk just shattered into like a gazillion little pieces. That's discouraging. All right. So what do we get?
Negative.
Do I need to factor out a negative? I got a first term positive. I'm good.
It's positive. Square root of 4.
Square root of 2 minus square root of 6 all over 4.
Okay, I was trying to. Yeah.
You cannot combine radicals
Yeah.
unless they are like to each other, meaning same index, same radicus. So just leave it like that. We're done. All right. Questions on this? Sorry, I didn't get the nose gesture there the first time.
Yeah.
Not sure I missed it. So anyway,
I was. Anyway.
it's okay. Hi, Jamie. Number 5, the tangent of 255. And Quentin, sometimes it really stinks to go last.
I know.
Because we've already used 2 ways to come up with 255, and I wonder if you could come up with another way to make a 255 degree angle.
I don't think.
I've got a great way.
Well, better than
I don't want to say the way that I'm thinking.
What are you thinking?
30 and 225. I don't want.
We already used that one anyway.
Oh, good.
That's one of the reasons I'm not letting you use that, because I don't want to deal with the 30. I really don't like 30.
350.
Oh, there's a thought.
Well,
Cheater.
Gotta help the homies out.
well, 315 minus 60.
Huh. No 30-degree angle. See? Yeah, the Chris. All right, so anyway, Quentin, what's my sum difference identity for tangent?
Tangent plus minus tangent all over 1 minus plus tangent tangent.
Good. Tangent plus or minus, in this case minus tangent, all over 1 minus plus, in this case plus. Tangent, tangent. You need to drop in the angles. 315.
60, 315, 60.
And now, anytime it says 315, of course, that's quadrant,
4,
reference angle.
45.
So, tangent of 45, 1, but in quadrant 4,
Negative.
tangent 60,
Square root 3 over. Yeah, square root 3.
and of course we keep the negative sign here, or the minus sign here, all over 1 plus, well, we just said the tangent of 315 was negative 1, so we put a negative 1, and the tangent of 60 we just said was square root of 3, so we put a square root of 3, but what is negative 1 times square root of 3?
Negative square root 3.
So really, this becomes negative 1 negative square root of 3 all over 1 negative square root of 3, right? That's just kind of cleaning up the look a little bit. Now what do we do?
Multiply by the conjugate, which is 1 plus square root of 3.
And in the denominator, of course, we do 3 things
Square first, square last, with a long sign.
to get.
Negative 2.
1 minus 3 becomes negative 2. In the numerator, we multiply first.
Negative 1.
Outer,
Negative square root 3.
inner,
Negative square root 3.
gives me,
Negative 2 square root 3.
and last,
Negative 3.
negative 3. We can combine the negative 1 and negative 3 to get
Negative 4.
negative 2 times the square root of 3 all over negative 2 gives me an answer of
2 plus square root 3.
and there's my answer.
Okay, so I actually had this because on this one I did do 255 for some reason.
Well, good. Good, all right.
Well, actually I had 2 plus square root of 3 over 2, but it's close enough.
Well, not really, but whatever. All right, questions on this? Now that we've had a chance to work some of these, we've had a chance to see them work. We did some yesterday. We feel like we're starting to get the hang of how to work some difference identities. All right, look at number
I
7.
thought I was about to say clear your desk.
No. We got more practice to do on this. We're not ready for a quiz yet.
Don't urge him to do that.
Stop. Stop, Chris.
Just remember yesterday, Ethan asked for a quiz in physics, remember?
That was not yesterday.
Or 2 days ago, whatever it
My mom
was.
likes it when I
asked for
my mom
points.
likes it when I put this in pre-cal.
I'm sending a link to your mother. All right.
To your mother.
Don't forget we're recording right now. Don't lie under oath. All right. All right, number 7, copy down on your paper. On page 116. Jamie, if you don't have your book, You're not off the hook. Hey, that rhymed. Because I'm going to write it on the board and you can copy it on your paper. Didn't rhyme. All right.
See you later. Number
Sine of lambda minus pi over 3 plus the cosine of lambda plus pi over 6.
I hate writing lambda.
You don't like lambda? It's easy.
I love lambda.
I like
I don't like mu.
what is the X?
The chi.
Chi. I love chi. I love them.
Well, this is just like it, but instead of going all the way through like this, you just go part way through.
Yeah.
It's the same basic stroke, right?
Mm-hmm.
Anyway, all right. All right. We're going to figure out what this is equal to. And I see a sum difference, in this case difference, with sine. So class, I should write sine, cosine, cosine, sine. All right? And keep whatever this SIGN is, and then drop in the angles.
Lambda.
Lambda. Square root.
Pi over 3,
Okay.
lambda, pi over 3. Easy enough? Then it says plus, so I put plus. And then it says cosine. Well, this is a cosine sum difference, in this case, sum identity. So I should write
Cosine is negative plus sine, sine.
sine, sine, sine. But this SIGN means we're going to change what was a positive to a negative. And then we drop in the angles.
A lambda
Pi
pi
over
over 6, lambda pi over 6.
All right. Easy enough?
Yeah, sure.
All right. Now, you can't do anything with the sine lambda because you don't know what it is. But you can do something with cosine pi over 3. See, lambda is an unknown angle. Pi over 3 is known. We know pi over 3 is the same thing as
60.
60 degrees. And what's the cosine of 60?
Square root over 3.
Cosine of 60, adjacent over hypotenuse.
Oh, yeah. I thought they
Square
were
root of 3 over
opposite.
2.
Oh,
1 or 2.
1/2.
Oh,
He sounded like he was crying.
I do the sine.
So we get 1/2 sine lambda. That's what this term becomes, a 1/2 sine lambda. All right, let's come to this next term here. What's the sine of pi over 3, or the sine of 60?
So that's a
Square root of 3 over 2.
Square root of 3 over 2. So we're going to multiply the square root of 3 over 2 times negative cosine to get negative square root of 3 over 2 cosine lambda. Make sense?
Mm-hmm.
Let's go to the next one. Cosine pi over 6. Well, pi over 6 is
30.
30. What's the cosine of 30?
Square root of 3 over 2.
So this is going to be a positive square root of 3 over 2 cosine lambda. At your seats, do the last one. What do we get, anyone?
One half.
negative 1
Yeah,
half.
one half.
Negative 1/2 sine lambda. This becomes a 1/2. Multiplied by negative sine lambda becomes negative 1/2 sine lambda. All right. Now I notice though I've got a positive 1/2 sine lambda and a negative 1/2 sine lambda.
Cancel.
Cancel.
I've got a negative square root of 3 over 2 cosine lambda and a positive square root of 3 over 2 cosine lambda.
Cancel.
In other words, this is a big nothing. Literally. It
What?
equals 0. No matter what angle you make up, if you subtract pi over 3 or 60 degrees and take the sine, and then if you take the same angle you made up and add 30 degrees and take the cosine and add those values, you'll always get 0 no matter what they
Can you do it
are.
on the calculator?
I guess you could if we had time, but we don't. We got to move forward. Maybe after class sometime you could do that. Just mark number 7 as one to test. Number 10, the secant of pi plus chi.
Yeah.
The secant of pi plus
I
chi.
love that.
And it
Pi plus
rhymes.
chi.
Unless you say pi plus chi, which just really
Yeah,
kills
yeah.
it.
Pi
All right.
plus chi.
Chi-chi.
Pie and cheese? I don't know. Anyway,
Pi and
who
chi.
eats
Pie
the
and
two of
cheese.
them?
Yeah.
I don't know.
I'm writing this picture.
Anyway,
Oh, we have mutation.
Anyways.
there's a storybook we have about this little church mouse critter, and he eats cheese and apple pie, and less like that just seems nasty to
Apple pie?
me. Apple pie and cheese.
Oh yeah, some people actually do that.
Yeah.
I don't know, they're weird. Anyway,
Cheese whiz.
so we see
Show
secant,
themselves.
and I'm like, wait, it's a secant, sum or difference, in this case, sum identity. But I got something special for secant, so I'm going to have to do
Reciprocal.
One.
1 over
Cosine.
cosine, cosine, sine, sine, sine. Where I drop in the
Pi.
pi and the
Chi.
chi and the
Pi.
pi and the chi. All right, and Again, chi or chi, however you want to pronounce it, is unknown. So we can't do anything with that. But I do know pi really means
180.
180. Pi is 180 degrees, which is a quadrant
4, 3, 2.
2 or 3 form of the reference angle
0.
0. Because everything's measured from 180, and how far from 180 is 180? 0. Okay, so we need to say, well, what is the cosine of 0?
1 over 0.
1 over undefined.
Cosine of 0.
1.
Cosine's adjacent over hypotenuse.
I don't have that in here.
Yeah, draw it real quick. Or think of your unit circle, the cosine line at
That's what I'm
0
trying to do right
degrees.
now.
Or picture the graph of cosine. At 0 degrees, where is the cosine? 1.
Yeah.
Or better yet, rather than thinking through the graph, if you're going to use the graph, at pi, where is the cosine?
-1.
-1. Because otherwise we have to say, well, cosine of 0 is 1, but in quadrant 2 or 3, cosine's negative. So,
But to do that, you have to have the graphs memorized to be able to do that.
don't you?
Yeah.
All right, then it says minus, and this is sine of pi. Okay, picture the sine curve. At pi, what's the sine?
0.
0. Or you could say, well, 0 degree angle. What's the sine line? That's nothing, right? There's no vertical line. Or special triangles, opposite over hypotenuse is 0 over 1. So we get 0 times sine pi or chi. Well, of course, anything times 0 is 0. So really, what does this become?
1 over -1 cosine chi.
1 over negative cosine chi. And what is 1 over cosine?
This is tangent.
No, 1 over cosine.
Secant.
But it's negative. So this is equal to negative secant of pi.
I knew we were going to circle back to it.
Questions on this? Jen Psaki. All right, number 12. Number 12, write that one down.
My bad.
Jamie, we heard that. What's more God heard that? He knows what's in your heart.
That.
I'm just kidding. I don't think she actually was like, do it, when Ethan said, end it all. All right. All right, she might have. I don't know.
Jamie's a savage, man.
She seems all sweet,
camera turns my way.
innocent and stuff.
The camera turns away and she's looking at him and he's like,
All right. All right, here we go. I see sine, some difference identity class.
Sine, cosine, cosine, sine.
Sine, cosine, cosine, sine. And then, of course, we have to put the positive because we don't change it. We drop in the...
30.
I like that. Let's just say 30.
180. 30, 180.
why do you have to be so smart, Quentin?
Minus, because he wants to get into college, minus...
45.
He's like, I just asked Mr. Tedeschi to fill out a recommendation. I better be real good while I wait for that recommendation to go through.
You guys have a recommendation?
Yeah.
You have to get recommendations to go to colleges. They always ask for recommendations, and preferably they want one from a
Oh
teacher.
no, I got
or,
2 that didn't ask for 1.
Really? They didn't? Well, yet. Not yet.
Yeah,
I don't know.
yet.
Unless you've been accepted into the college already. I don't know. Anyway, all right. Then we come to tangent. Of course, tangent class is obnoxious. It's going to be tangent
Plus
minus tangent
over
all over.
1 minus plus tangent.
And let's be smart like Quentin. And instead of writing pi over 4 and pi over 3, let's write...
45.
45.
60.
Oh, thank goodness they could put a 60.
45.
Mr. Tedeschi was having an aneurysm when he did
Oh, yeah, I know, because I struggle with algebra so much. All right.
I know. You're obviously
You're an algebra teacher.
I'm just that lazy.
He's obviously
All
a
right.
Spanish teacher.
All right, so, oh boy, let the fun begin. What's the sine of 30?
Oh no.
30 is 1/2.
What is this?
He is indeed correct. He's
All
one.
right, sine of 30 is what?
1/2.
1/2.
Half. What's the cosine of 180?
0.
Cosine curve,
That's a good guess.
halfway through is pi, or 180.
Oh, I'll
Negative
make it
one.
time for it.
All right, what's the cosine of 30?
Oh, the cosine of 30 is square root of 3. Okay,
Over 2.
we can stop now.
What's the sine of 180?
0.
Oh, put the paper away.
That's why you're doing so good, huh?
I just
Throw
pulled it
that
out
letter of
forever.
recommendation.
I know
out
you
the
just
window.
pulled it out. I could tell a difference in your answers.
Yeah.
I'm like, there's showing off and then there's showing off too much. I feel like,
He's cheating.
yeah, he got his chart out from earlier. Hey, but you know what? On one hand, smart because he didn't lose the chart.
Yeah.
I don't even
You know?
I didn't even know he had a chart.
See,
Anyway, tangent of 45. Tangent 45.
1.
1. Tangent 60.
Square root 3.
One.
Square root 3.
Square root of 3 over 1 or square root of 3. All right, tangent 45
1.
and tangent 60.
Square root 3.
I say we just said those. You should be able to get those pretty easily. Now, one of these terms gone just like that.
0.
Square root 3.
Square root of 2 over 0, super easy, right? Also, I don't have to really leave the 1 times square root of 3.
Yeah,
I
that's
could
not
just say
Square root 3.
that, right? So
Yeah.
now this is really easy. Let's get the easy part.
Negative 1/2.
Negative 1/2. I'm going to come over here and negative 1/2. Let that be easy. And then I've got minus all of this, right? Minus, and then this is going to become something. So let's kind of work this as well off the side. I got a 1 plus square root of 3 over a 1 minus square root of 3. And I need to do what here?
Multiply by conjugate.
Conjugate, which is
1 plus square root of 3.
Mm-hmm.
Why are you saying
That's right.
he is affirming that your answer was correct since he usually doubts it. All right.
I mean, you're not wrong.
So in the denominator, Christopher, what do we get?
That's good.
1 minus 3, 2,
No.
negative 2.
Thank you. All right. In the numerator, Chris.
Thank you. 1. 1, no. Outer. So it would be square root of 3 through square root of 3. 3.
Square root of 3 plus, okay, square root of 3 plus square root of 3.
Oh, 2 square root of 3.
All right, and then last,
3.
we add these together to get,
4 plus 2 square root of 3.
It's been a long time. Okay,
4.
give me a break.
And so this is 4 plus 2 square root of 3, all over negative 2. Now what I could do here, because this has a denominator of 2, is I could pull that out front, leave the 2, slide the negative out here, 4 plus 2 square root of 3, because now I'm subtracting a negative. But we don't subtract ever, we
Inverse.
add the inverse. And since they have a common denominator, you put it all over 2. Negative 1, positive 4, positive 2 square root of 3. This becomes
3.
3. So 3 plus 2 times the square root of 3, all over 2. And that's the answer to that.
I don't like that problem.
So basically, if we take 180 and 30, this is basically saying the sine of 210 degrees minus the tangent of 45 and 60 is 105 degrees. Well, tell you what, go ahead and put it on your calculator just for the fun of it. Sine 210 minus tangent 105, and we get some crazy decimal. 3.2-ish?
3.230. Blah, blah.
Yeah. All right, now, plug this into the
Why am
calculator.
I in radians? Why am I in rad?
Well, you could be, if that, in that case, don't type 210, do pi over 6 plus pi, and take the sine of that.
I got 3.232.
Yeah. Right now, over there, do 3 plus 2 times the square root of 3, and then divide all that by 2.
Same thing.
Same thing. But exact value instead of weird decimal, irrational decimal. Questions on this?
I don't like the way you smile when you say you're good on this because I feel like you're going to give us a quiz.
No, I'm just making sure we're good before we move on to the next thing.
The quiz is
Last time, don't
The quiz is
answer.
Monday when I'm brains are fried.
All right. Go ahead and take a look now at number 26 because we don't generally, the real point of this is finding these exact values like we've been doing, but it doesn't mean we couldn't use some difference identities in trig verifications. So let's take a look at a couple trig verifications that use some difference identities. So I'm going to write down number 26.
The only reason Mr. Ashley does is because he knows I'm great at these.
And we got the cosine of A and W, alpha and omega,
I want to
times the sine of omega minus the sine of alpha plus omega times the cosine of omega equals the sine of negative alpha. That's what we're going to try to verify here.
I'm gonna kill myself.
All right, anytime we see a sum difference identity for cosine class, we would write
Cosine, cosine, sine, sine, sine.
cosine, cosine, sine, make it negative, sine, sine. And of course we drop in the
Alpha, omega, alpha, omega.
and all of this is being multiplied by the sine of omega.
Please don't call me.
You're doing this with us. Right. And it says minus, so we put a minus. And then it says sine of alpha plus omega. Well, when I see sine of alpha plus omega, Chris, I should write
Sine, cosine, cosine, sine, positive between two cosines.
and drop in the
Not the A.
Alpha.
Alpha, and the W.
omega.
Alpha, omega.
And of course, all of this is being multiplied by the cosine of omega.
I don't either.
And fortunately, we've reached the equal sign, so we're done writing. This is all on the left side. And we're going to try to make all of this become a sine of negative alpha when we're done. All right, now, anytime you have a polynomial like x plus y multiplied by a monomial like m, class we distribute. Even if the m were after, you would still distribute, right? So I'm going to distribute the sine to this and to this. What do we get if we multiply sine omega by cosine alpha, cosine omega?
Cosine, alpha,
Cosine, alpha,
cosine, omega,
cosine,
sine,
cosine.
omega.
What do we get if we multiply sine omega by negative sine alpha, sine omega?
Negative sine alpha 2 omega.
Sine squared omega. Now here, it's technically a negative m that has to be distributed. Does that make sense? Just the negative and the m are split by the x plus y. So here it's going to be a negative cosine that needs to be distributed. So if we distribute negative cosine right here, negative cosine omega, excuse me, I get
Sine alpha cosine squared omega.
negative sine alpha cosine squared omega. And then here, if I multiply negative cosine omega, I get
Cosine.
negative sine,
Negative cosine. Sine cosine.
negative cosine alpha, cosine omega, sine omega. You better keep up with the Greek letters as we go, the angles as we go, or else it's going to make problems for you. All right, and all right, thoughts?
Cancel. Can we cancel stuff?
What?
The cosine alpha, cosine omega, sine omega.
Yeah, here I've got a positive cosine alpha, cosine omega, sine omega. Here I've got a negative cosine alpha, cosine omega, sine omega. They cancel. So all I'm left with now is a negative sine alpha, sine squared omega, negative sine alpha, cosine squared omega. I'm having a hard time keeping that equal sign lined up, huh? Thoughts?
There's nothing else you can cancel.
No.
So negatives. Stop. You click your tongue when you play.
And?
He clicks his tongue when he thinks he's like Pythagorean. Pythagorean.
Let me ask you, if
Yeah.
I gave you negative AC squared, negative BC, or AB squared, what would you do?
Factor
Factor
out.
out A.
You'd factor out a negative A, right? I'll leave you with C squared plus B squared.
Mm-hmm.
I've got a negative sine alpha sine squared. I've got a negative sine alpha cosine squared.
Factor out negative sine alpha.
Factor out the negative sine alpha to leave us with what in parentheses?
Cosine squared omega plus.
Oh, careful.
Or sine squared omega. Plus cosine squared omega.
Thoughts?
That's tangent.
Ooh.
Or that's one.
That's one. Now, if they were different angles, it wouldn't be anything. But because they are omegas, it's something. And so this is just negative sine alpha times 1. Again, you need to show the 1 so we know what happened. And, of course, anything times 1.
Itself.
So this is just negative sine alpha, which is
sine of negative alpha.
sine of negative alpha, all equal to sine negative alpha. And there's the satisfying check mark. at the end.
You're never gonna make us do this on a quiz, are you?
Why not? It was easy.
What?
It was a lot to write. I'll give you that. I mean, there's a ton to write, but like, you didn't even have to think about what to do. I mean, there's nothing else you can do but write it out. And then monomial times Poly distribution, we've been doing that since 8th grade. And then canceling, I mean, that was easy. You saw that step just fine. And then common factor, we've been doing that since 9th grade. And then Pythagorean, screaming at you to replace it with what is it? Easy negative angle identity. I mean, it's easy stuff. It's just a lot of
I
writing.
got any harder though.
Well, maybe. Let's take a look at number 29. Copy number 29 down.
I hate it here.
We need a whole page for this one.
Yeah, probably.
No, I only have one chalkboard and it must fit.
Oh, this one isn't bad. 29 isn't bad.
Don't, it's a fraction, so.
Which is
They're
this?
seeking.
Oh.
Yeah.
Yeah.
All right, so we got omega and delta.
Did we just make that capital delta?
Nope. Because the lowercase delta is cool. It's like an 8, but you don't finish the
I was about to say
8.
it's like an 8 that someone forgot about.
It's an 8 you don't finish, all right? And we want to show that that's equal to secant omega, secant delta, all over 1 minus tangent omega, tangent delta. Now, which side looks more complicated?
The right
The right side. But, strategy tip for you. Anytime you have a sum difference identity, it is automatically the most complicated side. This is more complicated than this. We're always going to start with a sum difference identity because you know automatically exactly what to do. What must I do here?
Make that a reciprocal. So 1 over cosine. So 1 over cosine, cosine, sine, sine, sine.
1 over cosine, cosine, sine, sine, sine. Cosine omega, cosine delta sine, make it a negative. Sine omega, sine delta. Now, as I look at this, you see I have a fraction. Is that a bad thing? No, because I want a fraction, don't I? Now, the denominator looks nothing like that. The numerator really looks nothing like that. Any great ideas of how to make this look like that? I didn't think so. Any great ideas of how to make this look like that?
I don't think so.
Secant over secant?
Why don't you just multiply it by that, and it would become that, wouldn't it? So we can at least make the numerator look good, right? Now, I'm going to have to shift my equal sign down here for a minute. All right, so we've got the 1 over cosine omega, cosine delta, minus sine omega, sine delta. And we're going to multiply this by secant omega, secant delta, over secant omega, secant delta, right? If I will multiply this, of course you can't just multiply the top, right? You got to multiply top and bottom by the same thing. But my numerator is going to be what now, class?
Secant omega, secant delta.
I'm halfway done. I've made the numerator match. Now it's just the denominator it's up to. And of course, if I had an AB times CD minus EF, I would distribute the AB to both of these, right? To get ABCD minus ABEF, right?
Mm-hmm.
Well, here I'm distributing a secant omega secant delta to this binomial. So what do we get?
Secant omega, secant delta, cosine omega, cosine delta, minus secant omega, secant delta, sine omega, sine delta.
What he said, right? You're writing that. I need to keep my equal sign way out here. Again, it's a lot of writing, but I mean, the work isn't hard. You knew you had to do this. And I'm trying to teach you the logic is the denominator's a mess and they're nothing alike. But the numerator's really straightforward. If I just multiply by that, I'll get it, right? And my numerator's done. Now, looking at the denominator, thoughts? Besides that it's really long.
Give me a second.
Let me move the lectern out of the way for you there. Because I like my numerator. I don't want to mess with my numerator now. It's good. It's exactly what I want.
Well,
That denominator's a mess.
Well, secant is reciprocal of cosine.
Okay, so in other words, you're saying I could leave the numerator, but your thought about the denominator is what?
Secant is reciprocal of cosine.
So, right, what?
1 over cosine omega. Minus 1 over
Okay, yeah, times.
cosine delta times cosine of 1 omega and cosine delta of 1.
All right, all that minus. I'm going to need more fraction mark here. Ethan, keep going.
Oh, sorry.
We have no idea.
Minus, okay.
Do what you did.
I'm still trying to catch up.
Oh.
Do you want me to take one?
Well, if I have to.
No. Okay. So 1 over cosine.
We're going to be here a while.
Yeah. 1 over cosine.
I notice one is a delta, one's the omega,
Yeah.
okay?
And sine over 1 and then sine over 1.
All right, now we're going to pick it up here now. Thoughts? The numerator again. I'm not going to mess with the numerator. I love my numerator because it's exactly what they're asking us for. But the denominator. Thoughts, Chris?
Cancel cosine.
Cosine omegas cancel.
Cancel the 1. Right, one you don't have to. Cancel the cosine lowercase
Deltas?
Yeah.
Yeah, cancel the cosine deltas. And so this entire term becomes 1. Getting really close. Thoughts on this other part here, Quentin?
Multiply the sine omega times the 1 over cosine omega.
We'll multiply it all straight across because nothing cancels, right? So when nothing cancels, you multiply straight across. What's my new fraction here?
Sine omega over cosine omega times.
No, just sine omega, sine delta in the top, right? Because 1 times 1 times sine omega times sine delta is sine omega sine delta. What about in the bottom?
Cosine omega cosine delta.
Right, cosine omega, cosine delta. But now we see, class, I've got, of course, keep the secant omega, secant delta, keep the 1, keep the minus. Right here, sine omega over the cosine, the sine delta over the cosine, they're all being multiplied together anyway, technically, right? So,
Tangent.
tangent, omega, tangent, delta, and that equals the secant omega, secant delta, over 1 minus tangent omega, tangent delta that I wanted, and the satisfying check mark at the end. For homework over the weekend, for homework this weekend, I want you to do page 116, number 8, page 116, number 8. I'm going to have you practice using these in the more practical sense for the homework. Find for me the cotangent of 105 degrees. Find for me the secant of 285 degrees. So 3 problems for homework. None of these big verifications, though. You're welcome.
What do you think about getting one?
Oh, no, there's some cool stuff in this section.
No, there's not.
All right, there's your homework, Jamie. Hope you feel better. Look forward to seeing you on Monday. Have a great rest of your day.